lab. Let's go find that organic layer solids, the one that's made up of a, what is it made up of? A neutral compound and dibromobenzene. So I've got a couple things going here. What's this one? This is the, this is either, yeah, this is it, an amine with benzocaine 1-naphthalene amine. Oh no, this was the failed one, that's right. Looks pretty though, huh? Remember, this one wouldn't dissolve well in the chloride. So, oh no, it wouldn't dissolve well in diethyl ether, so I had to switch to chloride. Yep. And here's that solid. So this is the one I need. I had it nested in a warm water bath. It took me longer than I thought to come back to get to it, but it's still here. So this is the unknown extraction organic layer. So this has dibromobenzene and either fluorine, benzyl, or benzoate. Yep. So we'll find out what that is, but first we have to get rid of the dibromobenzene. Because the dibromobenzene, we're treating that like an impurity. We already know what it is, it's not unknowns. We're going to try to get rid of that via crystallization, and then figure out which molecule we have with NMR and IR. Pretty looking, huh? So initially what I'll do is I'll weigh this. I'm going to dry the bottom of it with a paper towel. It's using that, it was nested in that water bath. And so let me pause the video for that. I'll record the mass of this beaker and the two solids in there on the same scale I used before, the top loading balance, but first I'll zero it. Looks pretty good. I'll do it one more time. Okay, close enough. So I'll put this on there and let's see what it comes out to be. So it looks like it is 257.36 grams. 36. Okay, I'll go 36 grams. No, it went back to 7. 36, 37. I'll go 36. So we're going to figure out which of these three is in here, but first we need to get rid of this guy. And we're going to do that via crystallization. So I was thinking about this crystallization and I thought, what solvent should I use? I'm pretty sure ethanol is a good solvent for this. But I'm going to act as though I don't know that. I'm going to do the crystallization. I'm going to test a couple solvents for the crystallization. I'm going to test out ethanol and methanol and see which one looks most promising. Usually in lab, if you're making a molecule that you've never made before and you can't find a literature reference for it, then you'll try out some solvents that you think might work just by considering polarities, saying, oh, I want something where the molecule's fairly soluble but not too soluble. So I got my methanol over here in the flammable cabinet. I've got ethanol as well. You want the crystallization solvent to dissolve your molecule okay. Not great, but not terribly, because you want it to be able to dissolve while it's hot, and then when you're hoping when it cools, it'll recrystallize. Okay, and then, oh, I just noticed too, over here, here's our aqueous layer product. Remember, that's a carboxylic acid from before. We filtered it off after it precipitated out. This aqueous layer product is either benzoic acid or orthotoluic acid. I'll get to that shortly. I want to do the crystallization first so that it'll have time to crystallize and I can filter it. It just seems to be the better time management idea. So what I'm going to do is I'm going to take a couple test tubes and label them and test out methanol and ethanol as crystallization solvents. I'll show you how I do that. It's simple. I'm just going to put a little bit of the solid in each test tube and then a few drops of these guys. See if they're soluble, very soluble at room temperature, they're not a good solvent. It's too soluble. If they're slightly soluble at room temperature, and then I heat it on the hot plate and it's soluble, and then I cool it and it crystallizes, it's perfect. So I'm going to check that. First, let me get a Sharpie and label these. I'll pause the video for that. So I've labeled my test tubes. So I've got this one labeled with my initials, methanol, the date, organic layer. And the other one's labeled the same, except for I'm going to test ethanol in this one. And the way I'm going to do it is I'm going to take and just scratch around the solid that's in this beaker with a clean spatula, loosen some up, and then put a little bit in the test tube. Each test tube, you see. Hello! Here we go. So I'll take a little bit of this solid on my spatula, not a lot. I'll put it in this test tube. So I've got about that much. I'll do the same for the other one. I'm not going to lose this solid in the test. I'm going to recover it and still crystallize it. I'll show you how I do that. Get some in there. There we go. Got a little bit in there too. I could weigh these out, but I'm okay with just a quick visual. This is just a quick qualitative test. So the first thing I'm going to check is ethanol. I got to make sure I have the right tube. See how it says ethanol? And this says ethanol. So I'll do that one first. I'm going to pipette out some ethanol and then push it right back in the bottle. Pipette some up. Push it back in the bottle. This way I can get this pipette evaporatively cooled and it won't drip as much on me. Then I'm going to put a little bit of this ethanol into my test tube. 4, 5, 6, 7, put like 8 drops in there. I'm looking at it. It looks like it's dissolving a little bit. Still a fair amount of solid on there, in there. I'm going to do a couple more drops. Let's go 1, 2. Looks pretty good. I'll let it sit at room temperature for a little bit while I do the methanol. So I get the methanol bottle and my methanol test tube. Make sure it says methanol. It does. This is the methanol test tube. And open the cap. Draw up some of this methanol. Push it back out. Draw some up. Push it out. Okay, that's probably good. And now here's my methanol. Trip in some 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I think I got about the same volume in that one too. And maybe a little less. Let's look, I'll compare them. About the same. Okay, now what I'll do is I'll heat them up on the hot plate, see if one dissolves sooner than the other. There is something to follow here though, so something to watch, to consider and to think about. The methanol has a lower boiling point. It's only a 1 carbon alcohol, so as I heat it, it's going to evaporate quicker. So I'll have less methanol if I heat it for very long. So I have to consider that. If I have less methanol and it's looking the same solubility, then it must be more soluble in hot methanol. All right, let's go over to the hot plate and check it out. Okay, I've got my ethanol, my methanol test tubes here on the hot plate. Let's watch and see how they do. You can see the methanol label, the ethanol kind of covering that, but the other one's the ethanol, the methanol at the bottom there. Looks like it's starting to bubble a little, huh? Now, is this gonna work? It looks like it's dissolving to me. The methanol is definitely boiling before the ethanol, right? That makes sense. Lower boiling point methanol. It's looking pretty good. Let's keep going. Yeah, it's looking pretty good. It's probably not the best thing to look at through video camera. But yeah, it's dissolving well in the methanol and the ethanol actually. I think both of these are looking like good candidates for crystallization. And oh, look at that. It's already, looks like it's pretty much all dissolved in the methanol and the ethanol actually. They're both good solvents, so we could use either of these for this guy. And if yeah, they're both looking good. I think they both dissolve completely perhaps, huh? And so we started with them not being soluble at room temperature, at cooler temperatures, but then soluble when we heated it. So that's a good crystallization solvent. So when I cool these, let them cool here, they should crystallize back out over time. I'll go ahead and grab my glassware for the crystallization. And while I'm doing that, these will be cooling, and I'll come back and I'll show you what we got in the video after a little bit of cooling. I'm going to use methanol because we haven't seen that one yet. And it'll be good for you to see the differences with using methanol as a crystallization solvent versus ethanol. I've got some glassware ready. I labeled it better this time. I labeled it with pencil on the white label there, where the organic solvents won't dissolve that pencil graphite. And I used a 25 milliliter Erlenmeyer. I think that'll be a good size to heat up my ethanol. And when my ethanol's heating, it'll bubble a lot, so I want to have boiling stones in there. See the boiling stones? I used again the polytetrafluoroethylene boiling stones, or the Teflon boiling stones. Okay, and then I've got my flask that I'm going to do my crystallization over here, labeled up organic MFS 4621. It's tried-rope methanol. These, one thing that's bad about these is they're small. It's hard to write on them on the small flasks, but I'll understand what that is. So I need to add my methanol to this. And oh, let's check our tests so far. Has there been any crystallization yet? No, they're still cooling. That's okay, we'll get to those shortly. And then my methanol, I need to add it to this. Let's see if this is gonna take me forever to pipette it in. It might be slower than I want. I might want to use a, yeah, that's gonna take forever. I'm gonna use a short stem funnel. Let me pause the video. Okay, here we go with the short step funnel and methanol. I'm going to fill this up about 20 milliliters. I'm going to try to. That looks pretty good. You don't want to fill it up too much because then it like can bubble out more often. I think that'll work. I'll put that now on the hot plate and let it start heating. Watching it carefully because methanol has a very low boiling point, and I want it to just boil nice and gentle. So I'll probably have to turn the heat down if it starts boiling too fast. And while I'm waiting for that to boil, I need to get my solid from this beaker, the big beaker that I had the organic solvent evaporate away from. I got to get that solid into this little guy. I'll show you how I do that. What I do is I just scrape around the solid in the beaker and try to get the majority of it out this way into the flask, Erlenmeyer flask. There'll be still a fair amount of solid left in here after I do this, but it's okay because I plan to get that out too. The way I'm going to get it out is instead of adding the hot methanol directly to my crystallization flask initially, what I do is I'll add it to this beaker to get the residual solid out, and then pipette that over into my crystallization flask. This way I can get it all out. Okay, I'll chop this up into smaller pieces so I can transfer it good. This transfer, I could use a piece of whey paper to do this, or scratch paper. Or I could try to do it via spatula. I think I'm going to try spatula. Yeah, I think that's going to work. So I did a pretty good job. I got most of the solid into my crystallization flask, but there's still a significant amount left in there. But I'm going to get that out though. As once my methanol is boiling, you'll watch me pipette some of that methanol first into the beaker, then to dissolve the residual solid there, and then pipette it over into my Erlenmeyer flask. And then once I've got the bottom of the Erlenmeyer flask coated with that methanol, I'll put it up here to keep it hot, and I'll continually add hot ethanol. And when I'm adding this ethanol, I need to do it quickly, quicker than ethanol, because methanol has a lower boiling point and it will evaporate quickly. So if I add the methanol slowly, as if I add, like, say 2 drops a minute, it might be evaporating 2 drops a minute, so I'm not making any net change in the total volume. So, but let's see the little bubbles forming on the boiling stones? Those boiling stones allow little bubbles to form instead of big bubbles that can bump out of the flask. So the boiling stones, or also as they're known, boil easers, are easing the boiling of this solvent, so it's going to be safe for us. Tiny bubbles. Okay, it looks like it's boiling pretty good. And my hot plate still has the light on, the green light by heat. That's telling me that the hot plate's not to the temperature that it's set at. It's above it, or it's below it. So I'm gonna go until I see that green light turn out and keep lowering the value. Huh, it's not working properly. It should turn on. That's okay. I'll keep it around here. Okay, so it's looking pretty good. It's boiling well. Now I will start by pipetting some of this out and into the beaker. See, you gotta be careful. It might drip a lot on you. I'm gonna spit some of this. It's pretty good. So I'm gonna come over here and actually, I want to hold that. I want to wash off this micro spatula. I'm gonna need to turn off the camera and readjust it. Okay, here we go. I'll clean off the spatula. My first allocation of aliquot, maybe, of boiling methanol. Oh, that shot on me. I rushed it. I should, you guys can see me good on the camera. I should have my beaker over here. So I'm gonna add some more. Try to get all that solid down to the side. I got some down there. Now I'll start pipetting this out and trying to suck up the solid, and I'll put it into my crystallization flask. And look at this now. Crystallization flask, it's coated all on the bottom. I could put this on the hot plate as well now. And I can try to get more solid out of here. And now this pipette is a bit contaminated, right? So I'll use a new one as for my crystallization solvent flask, so I keep that clean. Oh, I want to put this over here now. I'm already starting to run out of the methanol. The methanol boils away so quickly. It's okay, I can add more. Trying to get all these little bits of solid out of here. I didn't get every bit of solid out of the beaker, but I think I got plenty. So I've got a little bit of solid down here. That's okay. Okay, so back to my crystallization. My crystallization methanol solvent's running out a little bit. And I don't want to add too much of it yet to the crystallization flask because it's not boiling yet. It's still warming up because it was cooling. Maybe I'll lift this off for a little bit. Wow, so I don't want to just evaporate it all away. Waiting for this solvent to start going. There it is. Bubble off. The solid that we're crystallizing is acting as boiling stones now, huh? Looks like it's dissolving pretty good. I want to see it boil a little more, and then I'll probably end up adding more methanol. I went ahead and turned up the temperature a little more again. I to like it's like 140. And this is supposed to be degrees Celsius, but I don't know how accurate these numbers are. I go off of what I see of the boiling solvents. Okay, getting impatient. I'm gonna go 200. It's looking pretty good over here though. More and more dissolved, huh? See how the drips of methanol slide down the outside of the flask? The outside of this flask is acting as what we call an air condenser. So the liquid methanol is evaporating, the gases are hitting the outside of the inside of the glass, which is cooler, and then it condenses from gas back to liquid and drips down. This outside of this flask is cooled by air, so we call it an air condenser. So whoa, did we get there? I think we might be good, huh? I think it's all dissolved, yeah. Oh, good thing I didn't add any more. I could have been impatient and kept adding, but I didn't. I could take the methanol off, and now this one's boiling pretty good. It looks like it's all dissolved. I don't want to keep it on here too long now. Looks nice though, huh? Because it's going to constantly be evaporating some methanol. So I'm going to take it over to this wooden block to cool slowly, and I'm going to slow it even more by putting a beaker over the top of it. It's not sealed, it still has that opening on the bottom of the beaker there, but this will allow a fair amount of methanol vapor to build up in the beaker, which will slow evaporation, which will slow the cooling, evaporative cooling, and if you cool your solution slower, you'll get more pure crystals. They'll crystallize slower, and they'll have an ability to crystallize and dissolve, and when an impurity gets caught in the crystal, it has time to dissolve back out, so you can get a more pure crystal. And we'll let that go, and while that's going and crystallizing, cooling and crystallizing, I'll move back over to my aqueous layer. I'm coming to check the crystallization over here. Ooh, I think we have some crystals. Nice. Oh yeah, they look good. I'm gonna remove the beaker and let you watch it for a sec. It's cool the way they're twisting around, huh? Forming. I'll set up a video of this. Now I will do a vacuum filtration of my my organic neutral compound, separating it from the dibromobenzene. So here it is in here. Got a pretty good looking yield, huh? It's been sitting out a couple hours. It had a nice slow crystallization. I'm assuming it's very pure. And I cut out some filter paper. And I set up my filter flask, Buchner funnel, and it's attached to the water trap bottle, which is attached to the water aspirator and its splash guard. So let's stick the filter paper into here. I'll press it down in. I wanted to cover up all those little holes so I don't lose any crystals along the side. I think it's looking pretty good now. And I took my leftover crystallization solvent, methanol, the little boiling stones, and I put it in a beaker of ice water to cool it down, to help me transfer. And I chose a beaker that was just big enough so that the Erlenmeyer flask can't fall over. Good. And now to do this, I want to initially wet the filter paper down with some of this methanol, and then when I turn on the vacuum, it'll suck the paper down good to make it so that I won't have exposed little holes that my crystals can sneak by and get into the mother liquor. So how I start this again is it's at the back side here, but I turn this water on to full blast, and the splash guard is doing a good job. I don't see any splashes coming out of this thing. And over here, it looks like my my filter paper is sucking down pretty good. Push down a little more with this clean. And then the way I get my crystals into this, I have to be a little bit, I don't want to be too gentle, I don't want to be canned. So I kind of swirl it around and dump it sort of fast. There we go. Tap the bottom. And yeah, it looks pretty good. I like the look of those crystals. They're nice. I've still got some left over in here. A little bit didn't come over. I'm going to try using the cold methanol to rinse those into the filter flask, but I'm going to be gentle with this. I'm going to add just a little bit of cold methanol and swirl it around and look at it and make a decision. Is it dissolving those last bit of crystals too much? Because if it is, I don't want to pour it on my other crystals. No, it looks okay. So I'm going to swirl a little bit, dump it as well. This is doing two things. It's getting out more of the crystals, and it's also washing my current crystals with clean methanol to rinse off mother liquor with its dissolved impurities. I'll do one more of those. Seems to be going okay. Swirl, swirl, swirl. Dump. I've still got some crystals stuck to the bottom of this flask. I'm going to count them as lost. I'm going to say that's okay. And if I want, I can try to rinse these crystals a little more with fresh methanol. But I don't want to do too much, because every time I do rinse them, I'm dissolving them as well. If I just kept saying, oh, I want to clean up all the mother liquor, and I just kept putting more and more cold methanol, eventually all my crystals would dissolve. But that looks pretty good. I'm going to let this sit for about a minute under vacuum, and then I'll pull it out with the tweezers onto a watch glass, a clean watch glass. It doesn't have to be pre-weighed yet, because I'm just going to let it air dry. And this will air dry quickly because methanol is such a low boiling point. The last filtration we did was the precipitated orthotoluene acid from water, and we had to let that dry longer because water takes a longer time to evaporate. I think this is dried under vacuum long enough. So should I turn off the vacuum now? Should I turn off the aspirator, water aspirator while it's under vacuum? No. I want to first remove this top of the beer funnel. And I can even take this out if I want to be really sure of it. Now I know there's no vacuum here or here. So when I turn off the water, I won't get a backflow of water through the tube. And this guy, I'm going to take and carefully remove the filter paper and its crystals and put it on this clean watch glass. I don't know if I can do that. I need to get something to show you that. Oh, you know what? Something else I forgot to mention. I saw this on a video. I've never done this before. I can't believe it. But a cool way to hold your filter flask or any iron flask is use an O-ring like this. I mean, iron ring. Works out nice, huh? I've always tried to hold it with extension clamp. You can hold them this way too. I like it. So I'm actually going to use this iron ring to video moving that. I took the hose off of the mother liquor filter flask, mother liquor there, so I don't have to. I can use this O-ring to video. So let's do this. Oops. Let's go this way. So I'm going to carefully filter paper out of the Buchner funnel top. Looking pretty dry already. Yeah, I think I got enough of it out. And I'll let that air dry. I don't even have to let it air dry very long, I think, maybe about 10 minutes. And I'll be able to get the weight of it, the IR, and the NMR. That's the nice thing about methanol, such a low boiling point solvent. It can be used quickly.